Welcome to today's video. We are going to be looking at the principle of isostasy and isostatic balance. First of all, what is isostasy? Isostasy is the rising or setting of a portion of the Earth's lithosphere that occurs when weight is removed or added in order to maintain equilibrium between buoyancy forces that push the lithosphere upward and gravity forces that pull the lithosphere downward. In simple terms, we can describe isostasy as the equilibrium between the Earth's lithosphere and the underlying asthenosphere. It refers to the balance of vertical forces acting on the Earth's crust. Let us look at the factors that influence isostasy. These several factors can include variations in crustal thickness. A thicker crust will exert more downward force. Variations in crustal density. Denser crust sinks deeper into the asthenosphere. The topography. Mountains and valleys affect the distribution of mass, and also the redistribution of material leads to adjustment in isostasy. Before we look more into isostasy, let us first understand the different parts of the Earth's lithosphere and how it is related to isostasy. The lithosphere comprises of the crust and the uppermost region of the mantle. It carries the outer rock layers of the Earth, which is broken up into 7 large continent-sized tectonic plates and about a dozen smaller plates. The lithosphere overlies the hotter, more fluid lower part of the mantle, which is the asthenosphere. Going back to isostasy, we first have to know the link between the lithosphere and isostasy. For isostasy to occur, we need the balance between the lithosphere, the mantle, and the asthenosphere. This will then bring us to isostatic balance. Isostatic balance occurs when the lithosphere floats on the denser asthenosphere. This balance helps maintain the stability of the Earth. Isostatic balance is achieved when the lithosphere floats on the denser asthenosphere, much like an iceberg floats in water. This principle helps in maintaining the balance of the Earth's lithosphere by ensuring that the crust is supported by the underlying mantle. Isostatic equilibrium is achieved through 2 processes, which are isostatic compensation and isostatic adjustment. Isostatic compensation occurs when the lithosphere adjusts its elevation to achieve equilibrium. For example, when a heavy load like a glacier or a mountain is present on the lithosphere, it causes the lithosphere to subside into the asthenosphere. Conversely, when the load is removed, the lithosphere rebounds to its original elevation. This compensation process helps in maintaining the overall balance of the lithosphere. Now that we've looked into isostatic compensation, let us understand isostatic adjustment. Isostatic adjustment refers to the slow response of the lithosphere to changes in loads over long periods of time. It occurs through the process of viscous flow in the asthenosphere. When a load is added or removed from the lithosphere, the asthenosphere flows slowly to accommodate the change. This adjustment process ensures that the lithosphere remains in isostatic equilibrium. To put isostatic adjustment into simpler points, we refer to it as the up and down movements of the crust that occur because of two opposing forces. The crust will be pressed down on the mantle. The mantle will press up on the crust, and when the two forces balance, the crust moves either up nor down. When weight is added to the crust, it sinks until a balance of the forces is reached again. Up and down movements of the crust to reach isostasy is called isostatic adjustments. As the adjustments occur, areas of the crust are bent up and down. Pressure from this causes rocks in that area of the crust to deform. Going back to the example of glaciers, we say if glaciers once covered the land, the weight of the ice caused the crust underneath it to sink, and the glacier ice will retreat. The land will then slowly begin to rise again in response to its reduced weight. Hence, we will have isostatic adjustment occurring. Moving forward to isostatic rebound. It is the gradual rise of land after the removal of heavy loads. Examples include post-glacial rebound and rebound following the melting of ice sheets. This phenomenon occurs as the lithosphere adjusts to the removal of mass. Like any geological phenomenon, there are implications that occur. Isostatic balance has significant geological implications such as mountain building, which we define as the isostatic adjustment that play a role in the formation of mountain ranges. Subsidence. The sinking of land can occur due to isostatic imbalances. Formation of ocean basins. Isostatic processes contribute to the creation of ocean basins. In summary, the principle of isostasy and isostatic balance play a crucial role in maintaining the equilibrium of Earth's lithosphere. It ensures that the crust is supported by the underlying mantle, allowing for the dynamic nature of the Earth's